Hello, my name is Murray Otten-Pete, reporting in for ATM Climate and Weather of Alaska for Unit 14 investigation of Bethel, Delta, and Kenai data weather. Today we'll start off with Bethel, which is located on the southwestern part of Alaska. Bethel sits at 61 degrees north and 162 degrees west in southwestern Alaska. On January 29, 2019, the sun rose at 10:12 a.m. and set at 5:48 Alaska Standard Time with a total of 7 hours and 36 minutes of daylight. On March 25th, the sun rose at 8:30 a.m. and set at 9:16 p.m. for a total of 12 hours and 46 minutes. We will see a significant change in the temperature in March as there is longer daylight. The Bethel weather station readings were, this is the monthly average temperature for Bethel, where they had a monthly average of 31 degrees Fahrenheit. As we go into the monthly average temperature for Bethel, we can see that the readings were well below the average of 5 degrees Fahrenheit on January 26 through February 1st. The station reading for January 26 was at negative 15 degrees with a rise about negative 8 degrees in the midday. There was a steady temperature reading between negative 25 degrees Fahrenheit and negative 15 degrees Fahrenheit throughout the whole week until Saturday and Sunday. The temperature had a spike. In temperature readings of a high over 30 degrees Fahrenheit on Sunday and a low of 15 degrees Fahrenheit, which was 15 degrees above the average readings. On Saturday, the temperature reached the average highs and lows. I now present the pressure data for Bethel, which corresponds with the cold temperature periods with high pressure until Wednesday, and low pressure and a rise again on Saturday with a sudden drop on Sunday, which goes with the spike in temperature on Sunday. We now examine the humidity. At Bethel, the relative humidity is the broken down dots, and the dew point is the solid blue line. We start with the dew point reading, which is the absolute measure of humidity. The dew point stayed between 50% to 35% from January 26th to February 1st, then peaked up to 98%. On February 2nd, the relative humidity stayed above the dew point for most of the week until February 1st, where it went below the dew point, which corresponds to the higher temperatures. Now we will look at the station data for Bethel. Here we can see the lower temperatures than the average, and the pressure system, and the dew point, which is way below the relative humidity. On Sunday, January 26th, there was a high pressure to the northwest and low pressure to the south central. The shading indicates light clouds with foggy conditions. The isobars indicate winds from the southwest. On Sunday, February 2nd, there is a low pressure system approaching Bethel, bringing warmer temperatures, which goes with the station readings with a mixture of snow and rain and a mixture of thin and thicker clouds. On Sunday, March 29, 2020, a strong high pressure system bringing airflow from south to east with clearer skies and cooler temperatures, which is consistent with the weather station readings. Finally, on March 29, that was March 22. On March 29, a strong high pressure system bringing airflow from south to east with clear skies and cooler temperatures, which is consistent with the weather station readings. Finally, on March 29, 2020, there was a high-pressure system that took over much of Alaska, bringing clear skies to Bethel and cooler temperatures and record low temperatures. We go on to the map and GOES images for Bethel area. As you can see, Bethel's climate is greatly affected by the Bering Sea, which brings in cooler temperatures and offshore winds with no mountain barriers, which goes along with the station readings. And during the winter months, the jet stream is further north and is further south during the winter months. We now look at Delta, which is situated at 64 degrees north, 146 degrees west in the eastern interior of Alaska. On January 29, the sun rose at 9:32 Alaska Standard Time and set at 4:20 p.m. for a total of 6 hours 49 minutes of daylight. On March 25th, there was a total of 12 hours and 52 minutes of sunlight, which started at 7:23 a.m. and ended at 8:15 p.m. We expect to see significant heating due to the longer daylight hours starting in January. There was a steady rise in temperature up to March, where the average temperature sat at 29 degrees Fahrenheit. The average temperature started at 0 degrees Fahrenheit with an average high of 15 degrees Fahrenheit and an average low at negative 15 degrees Fahrenheit in January. Here we have the monthly average temperatures for the Delta area. Here we can see the temperatures were way below the normal average temperatures. The Delta is so much protected from the ocean elements. Had a mean temperature of negative 31 degrees Fahrenheit on January 26 and 25 degrees on February 2nd. The weather station readings were well below the average, staying between negative 36 degrees Fahrenheit and negative 15 degrees Fahrenheit from January 26 to February 2nd. These cooler temperatures are due to the prevailing winds, which makes Delta have cooler temperatures. The cooler temperatures are in large part due to the cold Arctic air mass and the prevailing winds from the Pacific. We now look at the pressure data for Delta, which corresponds well with the station readings. On January 26, there was a high pressure system on both sides of the Delta, which explains a reading of 1,015 millibars on the data collected. There was a drastic drop in pressure on Wednesday and a sudden spike in the high pressure between February 1st and 2nd, which explains the cooler temperatures. We now look at the weather maps for Delta on Sunday, January 26th. There was a trough of high pressure competing with the low pressure system in the Gulf of Alaska. The system brought in some snow with foggy and cloudy conditions. On February 2, 2020, a huge low pressure system brought in the clouds and precipitation in the form of snow, which corresponds well with the cooler temperatures coming in from the northeast. On Sunday, March 22, there were still some heavy cloud cover over Delta and some snow with southwest winds coming out of the Bering Sea. On March 29, the high pressure system took over much of the state of Alaska, bringing in clear skies and cooler temperatures for the Delta area, which corresponds well with the station readings of a minimum temperature reading of negative 21 degrees Fahrenheit and a temperature range of negative 9 degrees Fahrenheit. For the map and GOES images, on January 26, 2020. The Delta area, as you could see, had thick clouds on the visible image and on the water vapor image. On February 2, mostly clear skies over Delta with the high pressure system pushing in the early cold air mass, making for much cooler temperatures in January and February. We now move on to the Kenai data analysis. As we go into the Kenai area, at 61 degrees north, 151 degrees west at the edge of the Gulf of Alaska on January 29, Kenai had daylight for 7 hours and 35 minutes, sunrise at 9:29 a.m. and ended at 5:07 p.m. On March 25th, the sun rose at 7:48 a.m. and set at 8:34 p.m., giving a total of 12 hours and 46 minutes of daylight. The temperature range for the Kenai area was at negative 17 degrees Fahrenheit on January 26 and negative 15 on February 2nd, being in the Gulf of Alaska, where ocean land water distribution and ocean currents control the climate pattern. Here we have the average temperatures from January to December for the Kenai area. The average temperature was at 36 degrees Fahrenheit. We now look at the monthly average temperature for the Kenai area. The temperatures were well below average in January for part of February 1st, with a peak back to the average temperatures on the 2nd. As we now look at the pressure data for January 26th, there was a steady pressure readings of 1,016 millibars, which is evident with the temperature readings that day. On February 2nd, the pressure skyrocketed to 1,022 millibars, which explains the very cold temperature readings for that day. We now look at the humidity at Kenai. We start with the dew point, which is the absolute measure of humidity. As we can see from the chart, the dew point was below the relative humidity on January 26 at negative 20 degrees Fahrenheit, where the relative humidity was at 80%, and then a sudden drop to dew point at negative 10 degrees Fahrenheit and 60% relative humidity, which explains a rise in the cooler temperature readings at the weather station. We now look at the weather map for Sunday, January 26, 2020. For the Kenai area, which is located on the Kenai Peninsula at the tip of the Cook Inlet. On Sunday, January 26, there was a low stationary pressure system situated just below Kenai. Light clouds and winds coming in from the southeast. The two stronger high pressure systems to the north were the deciding factors for the cooler temperatures. On Sunday, February 2nd, there is a low pressure system heading straight for Kenai, which explains the blowing snow from the southeast with thick cloud cover and some snow. On Sunday, March 22nd, there is a much calmer weather pattern as the winds are coming from the south, with the high pressure system bringing in clear skies and cooler temperatures. On Sunday, March 29, with much of Alaska, Kenai has clear skies with a dominating high pressure system over much of Alaska. The winds are coming from the east, which is consistent with the weather station observation readings. We now turn to the map and ghost images for January 26, 2020. As you can see on the visible images, there is not much cloud covering over Kenai. on any of the maps. The water vapor image shows high clouds, which explains the light clouds on February 2nd. Thin gray bands of clouds. On February 2nd, there is a stationary low pressure system bringing in strong winds, light snow, and light covering. As for my analysis and general knowledge of the data that has been collected, I would think that the Kenai area would be most sensitive to the climate changes because of where it is located, with the jet stream and the Arctic air mass and the ocean affecting much of the climate in the Kenai area, which could bring floods, erosions, storms, and that is my presentation or my final for ATM. Thank you.